In the previous video, we have seen that the Mobius transformation that transforms minus I onto minus 1, 0 onto I, and I onto 1 is this one. And now to find to what curve is x equal to 0 transform under this transformation. Alright. So x equal to 0 is given. Alright. That means it is a relation coming from z. Okay. So therefore we need to solve for z this transformation, and so to that end we have from here I will say that wz plus w minus iz plus I, and z equal to your w, this one will be here, so it is w plus I and minus w plus I, so z equal to this, so it is x plus iy is this one, and we write in the real part and imaginary part. So what is w? U plus iv, so I can write u plus I v plus 1, and this is minus u plus I times 1 minus v, and so we multiply the denominator and numerator by the conjugate of the denominator, and I multiply this by u minus I v plus 1, so denominator is this one, and here we multiply this by u minus I v plus 1, so this is denominator. What is the numerator? So minus u square. What is the real part? Minus I and I, so it becomes what? It is, I think, plus 1 minus v square, right? And what is the imaginary part? Imaginary part is I, so yes, I, u and v plus 1, and here your I, so it is u and 1 minus v. Okay, so this is equal to u square plus v plus 1 whole square, and this is minus u square minus v square plus 1, and here uv and uv cancelled out, u twice u, so it is I times twice u. Okay, so we have got this, and that implies that your x equal to, what is the real part? The real part is u square minus v square plus 1 by u square plus v plus 1 whole square, and what is u? Y is minus twice u square plus v plus 1 whole square. So therefore your your x equal to 0 is transformed to so minus u square minus v square plus 1, this is x, and u square plus v plus 1 whole square, and that is equal to 0, and that implies that, so only numerator is 0, so u square plus v square is equal to 1. And what is this? This is the unit circle. So therefore you see that the this is the real part, imaginary part, this is z plane, and this is real part, imaginary part of the w plane. So this x equal to 0, the imaginary axis is transformed to the unit circle 1. Okay, so this circle, right? So similarly you can show what would be the right part. Right part will be what? The inside point or outside point. You can easily get from here, because if x is greater than 0, this implies that minus u square minus v square plus 1 will be greater than 0, and that implies that u square plus v square will be less than 1, right? So your right half plane will be transformed into the points inside, so this one. Okay, so this type of questions you can solve. All right, once you find the transformation and solve it for z, and some z conditions on z are given, so you can find conditions on u and v. Okay, so this is the way. And next I will show another example, and then I will prove that actually there is a unique Mobius transformation that transforms 3 distinct points from in the z plane onto 3 distinct points in the w plane. Okay, so there is a implicit formula for that. This is not implicitly, so we explicitly found the Mobius transformation here from the properties, but in that case we will do we will find an implicit formula involving z and w, so that gives the transformation, Mobius transformation, transforming three distinct points to three distinct points. Okay, thank you.